Welcome to the Global Math Department. My name is Lee Natero, and I'll be your host tonight. Tonight, we're going to hear from Erick Lee and Sarah Furman. Before we begin our session, I'd like to tell you a little bit more about the Global Math Department. The Global Math Department is an organization that is run entirely by volunteers. To keep the free, high-quality PD, we need webinar speakers, webinar hosts, and writers for our newsletter. Newsletter writers share about an area of math or math teaching that resonates with them or discusses recent math blogs that help teachers reflect on their practice. If you'd like to volunteer or know someone who would be great in any of these areas, please have them email us at globalmathdepartment@gmail.com or have them reach out to us on Twitter. Before I introduce our speakers, I'd like to explain how our webinars work. Our webinars are recorded and are available about 24 hours after the meeting ends. To view the recording, you can use the same link you used to get here tonight. The Global Math Department community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. And if the chatter gets busy, I'll be sure to catch your questions for the presenters to be addressed at the end of the presentation. If you haven't already done so, please introduce yourself in the chat, telling us what you teach, where you teach, and what your Twitter handle is if you have one. Great to see people from all around the world tonight. As I mentioned, our webinar speakers are Erick Lee and Sarah Furman, and they'll be sharing on the topic, the Rosenthal Prize. Erick is a 712 mathematics support consultant for the Halifax Regional Center for Education in Halifax, Nova Scotia. He shares his thoughts on mathematics at pbbmath.weebly.com. He is also the president of the Nova Scotia Mathematics Teachers Association, an NCTM affiliate organization. Sarah Furman has a BA from University of Michigan with a double major in mathematics and English and a master's in curriculum and in teaching from Michigan State University. She's in her 23rd year of teaching at Inland Lakes High School, where she has taught both math and English. She's a Desmos Fellow Cohort 4 and a member of the Open Middle team, where she tests and edits content for openmiddle.com, a free mathematics resources for teachers. She has presented multiple times at state, regional, and district level conferences, and she is a member of the Rosenthal Prize Institute in 2022 in collaboration with the National Mathematics Museum. She's worked to build relationships with her students and continues to implement the strategies outlined in Peter Liljedahl's Building Thinking Classrooms in Mathematics within her own classroom. I welcome both Sarah and Erick.
Great, thank you for the introductions, Lee. So we're going to talk tonight about the Rosenthal Prize and the Rosenthal Summer Institute, and all of the lessons that are out there are the previous prize-winning Rosenthal Prizes. Sarah and I met each other last summer, where we were both part of the first cohort of the Rosenthal Summer Math Institute, which we'll be talking about later, and how you might be able to apply for that and to be able to attend that institute in New York City at the National Museum of Mathematics. Sarah, do you want to say hi?
Hi, everybody. Thanks for coming.
Great. So tonight, like I mentioned, what we're going to talk about, I'll give you a quick background about the MoMath. So this is a short name for the National Museum of Mathematics in New York City, and a little bit of background about what the Rosenthal Prize is and how you might go about applying for it. We're going to talk about the collection of lessons that's been accumulated that is shared by the Museum of Mathematics for teachers to use in their own classrooms. Then we're going to take a little bit of time to actually try out one of the previous prize-winning lessons. And then after that, we'll have a chance for some questions, and then we'll talk about applying, how you go through the process of applying for the Rosenthal Prize. And then at the end, the last part of the night, we'll talk about the Summer Mathematics Institute and how to apply for that as well. The applications for both of those are not arduous or complicated. So we really do encourage people to apply. I never thought I would get accepted to the Summer Math Institute. In fact, I think just about everyone that was there in the summer were kind of surprised they were chosen, and so sort of pleasantly surprised that didn't think they had much of a chance to get selected, and yet there they were. So it's a really nice opportunity to get to participate in something like that. As always, I'm just going to keep presenting. If you have any questions during the night, please type them into the chat. If I'm chatting, then Sarah might answer your question, or if Sarah's chatting, I might answer your question. So it's great to see you all. So a little bit of background about MoMath and the Rosenthal Prize. So the National Museum of Mathematics just actually celebrated their 10th anniversary. So they've been a physical museum in Manhattan and New York City for a little bit over 10 years now. The actual museum started before that. They started as an idea, and they had a traveling roadshow, I guess you would say, that they had a bunch of exhibits that they took on tour through science and math museums or science museums around the country, and put together a bunch of exhibits that they thought would bring out the beauty and joy of mathematics, and to change people's conception of mathematics from sort of the computational drudgery to something that's interesting and curious and engaging. And so that's what they did when they established the physical museum in New York City in 2012. So you can see there on the left, there's a picture of sort of the iconic square-wheeled tricycle. It's right in the lobby as you enter. It's kind of it's the iconic thing you do when you visit the museum. You'll notice there's someone there in a yellow T-shirt. The nice thing about the museum is it's staffed with lots of like mathematics graduate students that are there to engage you in the mathematics and to prompt you with questions, thinking questions about the mathematics you're seeing, and to get you to think a little bit more deeply at whatever level you're at. So you'll notice lots of kids are riding bicycles, and they'll ask specific questions to students, to younger people. And when an adult gets up there, they might challenge them with a little bit more deeper thinking. So there's lots of differentiation at the museum that lets you to engage in the mathematics you see there at whatever level of comfort that you have with mathematics. So it's a real sort of outreach to people to think about ways to inspire curiosity about mathematics, and to get people to thinking about the beauty and joy of mathematics. And it's very engaging. There's lots of exhibits. It's actually on 2 floors. That's the main floor. And then downstairs, there's additional exhibits. There's an interactive floor with lots of programs running on it that you engage with. And there's also some rooms and classrooms and things downstairs as well. The picture on the right is actually a picture of Ralph Pantozzi, who is one of the winners of the Rosenthal Prize, I believe it was 2014. He's on the right, and the person on the left is Sal Rosenthal. He's actually the person that has set up a fund for the funds for the prize money that's associated with the prize. So not only is the prize is associated with, there's like a $25,000 prize for the winning lesson each year. So I think we'll move on from there. So I think Sarah's going to talk to this one. So the prize is for an innovative mathematics lesson. So these are sort of the things that they're looking for in that sort of lesson.
So when we were at the museum, we bounced between the exhibits and then looking at the lessons that had previously won the Rosenthal Prize. And there was just a lot of parallels. And what they're looking for is something that's unique. And even if it's an activity that you have seen done before, it's about how you package it and present it to your students in an inspiring and unique way. And so, and one of the examples we talked about when we were out there was like the Barbie Bungee lesson. And if you say Barbie Bungee, people know what lesson you're talking about, but people have put their own spin on it. Well, the idea is that we're creating lessons that are unique and that have that unique spin on them, that they are inspiring and engaging, that kids low floor, high ceiling, that there's an entry point for all your students to get into it, and that there's a ceiling on it that's pretty high, so that there's more math to be done than just one level, that you can get to that rigorous level, that it's connected to content. And let's see, does it inspire kids and teachers to want to do more with math? Is it engaging? I mean, are the kids jumping into it? The other thing we talked about is how it has to be replicable. You can't have a ton of expensive equipment or huge technology asks. It's got to be something that a classroom teacher who is pressed for time can look through and put together in a 45 to 50-minute lesson. And so the library of lessons of previous winners, and there's these lessons that are available to teachers. So we wanted to talk about that, but also to get teachers thinking about, if you're sitting on a really good idea, the window is open to apply, and it's a $25,000 prize. And I think they gave out 10 grand. And Eric, I'm assuming you'll jump in if but they do give out monetary prizes after the 25,000. I think last year they did 25,000, 10,000.
I think there was like 4 prizes last year.
Yeah. So we spent a lot of time at the Institute talking about these innovative math lessons and what was there. And then also to prompt us to think about getting the word out to teachers that there are a lot of great lessons in the hands of educators across the world, and they want you to apply so that these lessons that maybe live wherever you live, we all know that they're there and we can start using them with kids. So, Eric, did I miss anything?
No, that sounds great.
Okay. If you guys have questions, feel free to drop them in the chat. And I think, Eric, the plan is we're going to look at one lesson in depth, and then at the end, we're going to talk about tips to apply, and also what the application involves if you think you've got a really good lesson.
So I just wanted to mention, some of you may have seen, if you're on Twitter or follow Dan Finkel, he actually was a winner this year. He was he wasn't the grand prize winner. He was one of the runner-up winners. But if you follow his newsletter, I think his most recent newsletter has a description of the prize lesson that he submitted for the Rosenthal Prize, and the one that was one of the winners this year. There's a whole thing. This actually prize has actually been going on longer than the physical museum existed. So there's actually 10 plus years of prize winning lessons. And this being one of them. This one isn't on the Museum of Mathematics website yet, but it will be shortly, as well as all of the other winners from this year. I think it was just like 2 weeks ago. I think February 8th or February 10th was I think February 8th was the award ceremony at the National Museum of Mathematics for this year's prizes. So speaking of those prize winning lessons, I am going to put this link in the chat as well. This is the link to the Museum of Mathematics website, where you can find a list of all the prize winning lessons. So I'm actually going to change my screen here and share the screen, the link that I just showed you. See if this works. So this is the Rosenthal Prize page on the Museum of Mathematics website. You can see there's a big red button here for applying for the Rosenthal Prize. The window is open now, so you can apply anytime. And then the application window closes on May 15th. So there's lots of times to think about what a lesson that you might want to submit will be. Also, if you continue scrolling down, you'll see some pictures of previous lesson winners. You might notice David Porras on the left side there. If you're interested in Mathagon Polypad, you've probably seen videos from him. And if you continue scrolling down, you'll see a list of all the winning lessons from previous years. So there's quite a collection of lessons, and we're gonna try one out here shortly. So what we're gonna do is, I thought instead of just talking about all those lessons. I'm going to go back to our slides here. We'll actually give one a try. And so the one we're going to try, we're going to go through about 15 minutes or so, is the dice auction. So the dice auction is a lesson that was submitted by Nat Banting. He's a teacher from Saskatchewan. It was the 2019 prize-winning lesson, and it's about probability. So it's sort of an introductory probability lesson. I think Nat Banting was the first Canadian winner of the Rosenthal Prize. And in this lesson, he's talking about probability. But one thing that's nice about some of these lessons where it can be used at lots of different grade levels. It could be an introduction to probability at a very young grade level, or it can be a review of probability before you get into more complex probability topics later on. So I've done this with high school students as a review of probability before we got into more complex topics around probability. So to start off this lesson, I thought we'd start with a would you rather question here. So if we were to roll a pair of dice 20 times, which would you rather have? Would you rather have $1 each time a double was rolled? So 2 3s, 2 2s, 2 5s, 2 6s. Or would you rather have $1 each time both dice are either a 4, 5, or 6? So it could be 5 6, it could be 4 6, it could be 5 5, a double that would have won you on the other one. So think about it for a second. I'd like you to actually put your answer into the chat box. Which would you rather pick, doubles or 4, 5, 6, as far as earning money from 20 rolls of a dice? So I see a lot of people saying 4, 5, 6, and this is what I found with older students that have a little bit more intuition about probability, often say 4, 5, or 6. For students that aren't sure, this is exactly the information that you need to know in order to be able to access the dice auction lesson. So I often start with this would you rather as an opening question before jumping into the actual auction itself. And show students 2 dice grid like this, showing you all the 36 different possibilities that are possible when rolling 2 dice. So then we can actually share a tool with students that they can use to make decisions between 2 different items. Because what we're doing in the dice auction lesson is we're actually auctioning off these opportunities of dice rolls. And students have to have some sort of entry to be able to say, which one is a better value? Which one of those 2 options would be worth more money if I was to bid on them? So we can say if we were to look at the doubles, well, on that slide, we can see that there's actually 6 different ways of getting doubles out of that 36. So a 1 in 6 chance, or a 6 out of 36 ways, which is a 1 in 6 chance. So if we were to actually roll 20 times, how many times would we expect doubles to show up? So you can answer that question in the chat. If you think about it, if we rolled 20 times, how many of those 20 rolls would you expect to be doubles? Somewhere around what number? All right, somewhere around 3, right? 1 6 times 20. So it's a little bit more than 3. It's like 3 1/3 is what we'd expect. But because we're only rolling 20 times, that's a very small sample space. So it might be 2 times or 4 times or even 0 times. We don't, because it's such a small space, we'd expect it to be around 3, but we're not guaranteeing it's 3. The probability of rolling 4, 5, or 6, if we can see, it's 1/4 of the quadrant of one corner of this grid right there. The 9 different ways on the bottom right corner of this array of dice are all the ways you can get 4, 5, or 6 on either dice. This one is a little easier to compute, right? 9 out of 36 ways is equal to 1/4, 25% chance. So if you were to roll about 20 times, we'd expect to get about 5 rolls of 4, 5, or 6. So everyone who said 4, 5, or 6, you're definitely you'd expect to make money more often with 4, 5, or 6, but you're not guaranteed. there are definitely times that the doubles might end up being more. And with students, I'll actually go through and we'll roll 20 dice a few times, see how many times it takes before there's actually more doubles than 4 or 5 or 6s. And it usually doesn't take too many tries because it's such a small sample space. So this is the background information that students need to be able to access the dice auction. So in the actual auction itself, there are going to be 15 different lots. And each lot is one of these probability statements about the result of a pair of dice being rolled. And if you win that lot, then when the 20 dice are rolled at the end, you'll get a point for your team each time that statement is true. So the strategy is each team of students is given a set amount of money, and you have to see if you're going to auction off these lots. Are you going to try and to bid on the really highly probable lots and probably have lots of bidding wars for those really probable lots? Or maybe you'll try and get less probable lots at a lesser price. So maybe you're going to try and get a bunch of not very likely things, but you have so many of them, you might outnumber the team that only got one really likely thing. So like I said, at the end of once you've auctioned off all 15 lots, we actually roll the dice 20 times and we calculate how many points each team got, and you're trying to get the most points after those 20 rolls. So that's how the dice auction is run. To make it a little bit more engaging, you can make a little auction paddle. Like when I did it in class, I just hot glued a index card to a popsicle stick for each group, and they were able to have one person as the designated bidder for their team. I also borrowed from the student council their gavel, so we were actually able to have an actual auction gavel, and it made it much more of an event to have during the class. So here's an example. The double is rolled. So I used a Mathagon polypad to roll the dice. I didn't do it like this. I did it one at a time to build the suspense, but we can practice that by rolling and seeing. We practiced this roll about doubles, and you notice that it ended up happening 5 times here. So that team would have gotten 5 points, which is actually pretty lucky because we don't expect to be 3 or so. So they got more than was expected with this roll. And then here's the instructions for the auction itself. So each team, so this is how I did it. Each team, I gave them $100 to bid with. Some teachers I know actually print off classroom cash and slice it all up. I just have an old Monopoly game, and I just use a bunch of old Monopoly money instead of making my own. Each team has a designated bidder. They get 5 minutes to look over all of the lots before they start bidding. This is really important time for students to think about the probability of each of those things and make a strategy about which ones they want to bid for. They'll have a handout and they can make notes with their team so they can talk about what they want their strategy to be. Just to keep the auction rolling, we started a minimum bid of $5 and we only bid in $1 increments. Otherwise, the bids could get very long and protracted. If you thought the bids were taking too long, you could up that from $1, but usually in the heat of bidding, some teams would start bidding $5 increments or $10 increments or go straight to $50. So it would get exciting pretty quickly. And then there's 15 total lots, and I usually took a break after 5 lots and 10 lots. If you had smaller groups or a different amount of students, you might just break it in half and do a break halfway through. But they need some time to discuss halfway through or partway through about where they're at and if they want to change their strategy. And at the end, we roll some dice and see who's the winner. So here's a list. It's a little small here, but here's a list of the 15 lots and the handout that the team members get to make their plan or their strategy about which of these lots they want to shoot for and what they think their maximum bid price might be. And then there's a picture there of each of the lots I printed off on a piece of cardstock so that I could hand it to the team so they had the physical thing of the thing they won that they exchanged their money for. And that's really the way it works. That's the dice auction. It fills up a class time. It's a 45. The actual auction itself takes about 45 minutes. I usually spend about 15 minutes on the would you rather question in the beginning to talk about probabilities, to make sure that every student had a set level of understanding of probability before we got going into it. Doing it in groups also helps. So if students not so sure, they can talk to each other and talk about the probability and things like that. What I thought we'd do is we take a minute to actually try and see what an auction might look like. So we'll say that we've already completed the auction and you have got some lots, and we're going to roll some dice here. So we're going to drop this link into the chat. Let's see, I can do that. So there's the link in the chat. If you want to click that link, and you don't have to log in with Desmos, you can just type in guest if you want, and we'll go through this together. So I'm going to change my view here to be the screen. So the first screen when you get here is the 3 lots that you've won. So let's say these are the 3 lots you've won. So you've run lot 1 that says a double is rolled. We have some experience with that. We said lot 3, both numbers are greater than or equal to 5. So it's not as good as the 4, 5, 6 one we saw earlier. This is just 5 or 6. So both numbers need to be 5 or 6. And the two numbers are consecutive. So 1 and 2, or 2 and 3, or 3 and 4, or 4 and 5. Any roll where the 2 dice are consecutive numbers. So we're just going to make a prediction here. So there's a table on the right here. In 20 rolls, about, you can calculate if you want to, or you can just make a guess, about how many rolls do you think would happen if you rolled that? I'm just going to put on some pacing here for now. It looks like we've got a lot of good estimates coming in. I think the double is rolled and the both numbers greater than or equal to 5 are fairly easy ones to estimate. The 2 consecutive numbers, that one gets a little trickier to estimate. You can calculate. And remember, we're looking for how many successful rolls out of 20. So how many times do you think that's going to happen out of 20? So we're not looking for the probability of success. We're looking for your prediction of how many times you think you're going to roll that lot out of 20 rolls. So it should be a number between 1 and 20. I'll give it one more minute here. Looks like most of you have some predictions. I'm going to open up the next slide here. And on this next slide, we're actually going to give this a try. So what we have here is in this Desmos slide, we have 20 dice. And how you roll dice in a polypad is you actually have to take your mouse and you will drag the mouse over all of those dice. And in the bottom left, you'll see a tab that says roll. And you click roll and it will make a little noise and your 20 pairs of dice will roll. So now I can say my first lot was a double is rolled. So for me, you can do this on your own on your slide. I'm going to see how I did. So I'm going to look at doubles first. So I'm going to use the pin here to draw my doubles. I got 1 there, 2. I got 3. Looks like I got 3 doubles, which actually is right about what we'd expect, right? So it's very close to what we would expect to happen. So both numbers are 5 or 6, while the 2 5s, that's also both numbers are 5 or 6. The 2 6s are also both 5 or 6. So it looks like there's 4. That one is 5 or 6 too. So 1, 2, 3, 4, 5. It looks like both numbers are 5 or 6. And 2 consecutive numbers. This one often surprises me of how many times it happens. 3, 4. There's 1, 2, 3, 4, 5, 6, 7, 8. So I got 2 consecutive numbers 8 times. So you'll all have different amounts on your own screen. So if you take a look, see if any of you have rolled some dice. So if you want to use that ink pen, you can use the pen to write in with your mouse how many times that you rolled that. And I'll open up the last slide here. So the last slide is, how close was your prediction? So I'm going to close that. I'll just get rid of the pacing. So the last slide is, how close was your prediction? So did anything surprise you? Was one of those more or less than you would expect to happen? I'm always surprised at how often 2 consecutive numbers happens. It seems like it's always, and I guess I should go and actually calculate the probability on that one, but I always seem surprised by it. But you may have been surprised by one of the other ones. So I'll just give you a minute. So some of you have responded to how it happened. So it looks like one person said doubles and consecutive numbers were what I expected, but the 5, 6 was less than I expected. Yeah, it was the consecutive was same as I expected, but I was still surprised by that. And I think it's nice to have this sort of response, because sometimes students are say, well, the probability was I should have gotten 3 for doubles, but I got 5 or something. So this is a really nice way to talk about, because 20 rolls is such a small sample size, that is oftentimes where your prediction is going to be off, because it is such a small sample. If we rolled 200 times, it would be much closer. Everyone would be much closer to their prediction because of that law of large numbers. That the larger the sample size is, the more likely that probability is going to be the same. So lots of opportunities to talk with that one. I'm going to stop sharing that screen. I'm going to leave that open. I'm going to go back to our slides here. I'm going to leave that open, but I'm going to go to the next slide here on the screen. If you want to continue on with the Desmos, that's fine, but I'm going to go back to the other slides here and talk about how this went in the classrooms that I did it in. I know the slide is a little small, but you can see I wrote down what the result was for each of those auctions. The very first lot is actually that doubles lot. And so you'll see what it was bid for. And the whiteboard on the right is actually the results of that. And you'll notice the very first one went for $25 out of the 100. Everyone had $100. So one team spent a quarter of their money on that. And if you look, you notice that doubles actually was really lucky. That in this case, there were 7 doubles rolled, which is way more than the 3 you would expect of 20 rolls, right? So not only was it way luckier than they predicted, they got it for a steal. So that team did really well. You might notice the second team bid their entire $100 on one lot. and it wasn't that probable of a lot. So they didn't do so well in this one. One of them, though, sometimes you do get really lucky. So lot 11, it's the one right after the line, the second line there. Lot 11 is both numbers are equal to less than or equal to 3, which is the same probability as the 4, 5, or 6 we talked about earlier. But this one is 1, 2, or 3. So we'd expect a quarter, 25%. So we expect around 5. And this time when we ran, when we rolled the dice, it actually happened 11 times, more than half of the times that both numbers were 1, 2, or 3. So that team was like super lucky, and they only cost like $25 for that one. So they got really lucky on that one. So sometimes because it is a small sample size, you'll get lucky. Another thing that we talked about when we did this is the psychology of money. Some people get really into auctions and bidding, and bid way more than the item is worth. It's sort of like, bidding on something on eBay, where you might end up spending way more money than you had anticipated just because you wanted to win. That psychology behind auctions and winning and wanting to beat the other team that's bidding against you. Sometimes that has an impact here as well. So sometimes there are some other conversations that come up about money and bidding and auctions that you didn't plan on with this lesson. So I've done this lesson several times, and I found that to be a really fun and engaging lessons. Students remember this lesson for a long time, and they remember about probability. So it's got all the hallmarks of a good Rosenthal lesson. It didn't take any materials. I just printed off some cards. I borrowed a gavel from another classroom. If you don't have your school doesn't have a student council with a gavel, you can, bring in, a meat tenderizer or whatever. You can make do with the things you have around the classroom. So it was, and when you actually look at this lesson, all of the handouts and all of the cards are already there. You just print them off, cut them up, and go. So there was very little prep with this for this lesson for me. It was easy to run, and the students, it really made an impact with the students. So those are all things that are important features of a good Rosenthal lesson. So I thought this would be a good one to do together in our short time here tonight. So I just want to show, so that one was probability. Here are 4 other lessons that I really think are great lessons, and show a variety of the different types of lessons that are there. They're not all, they're all different aspects, right? So Ralph Pantosi's winning lesson was about random walks and about, actually, Sarah, maybe you want to talk about this one. I think you've done this one with your class, right?
Yeah, I did random walk first week of school. This is the first year I haven't taught middle school in maybe 15 years. So I used random walk in the first week of school just to introduce norms and expectations in my classroom. And the crux of the lesson is they are flipping a penny, and if it's heads, you take 1 step forward, and if it's tails, you take 1 step back. And so their movement is dictated by the heads or the tails that they flip on the coin. And you kind of have them practice a little bit, but essentially what you have them do is they do their walking. And if everybody, theoretical probability would suggest everybody has the exact same number as heads as tails, and you end up where you started. Well, it doesn't end up that way, but then the kids walk. So they're in, I should show the video, but they take their steps, and then they all turn 90 degrees, and then they walk. I had them do this outside, and then we walk towards a line in the parking lot, and it looks like a stats curve. It's like a human. You have more people around 1, 0, and -1, and less kids around the numbers. Like if you had flipped 8 heads in a row, you'd be at 8, or if you had hit 8 tails in a row, you'd be at -8. So it's engaging, it's visual. And much like Nat Banting's lesson, where he took something, rolling dice, but he kicked it up a notch with an auction and made it collaborative. And that's the innovation piece of it. And Ralph's lesson was, again, it's flipping heads and tails and theoretical versus experimental. And then you throw in the, taking one step forward on a number line based on what you flip, and then creating, that the stats curve with human beings as a whole class was really, we all had to work together. My classes loved it and they thought it was really cool. But like Erick said, once you find these lessons, they're there, it's ready to go. The handouts are there. You don't have to create a bunch of materials, and it's things like coins and dice, and it's very replicable. And that's the other piece, is that the judges want to see something that people in any classroom can get into the lesson, that students, regardless of their math background, can get engaged in what you're asking them to do and gain access to some math that maybe they didn't have access to. And so that's kind of the goal of the lessons.
Great, yeah. So there's creating color combos. That's from Tracy Jackson's lesson, and that's about proportions, mixing different colored liquids together in different proportions to try and get different shades of color. So it's a proportions lesson. There's a Dwayne Griffin's lesson about statistics. She had a trimathlon, so she had 3 different physical activities where students were doing these and gathering statistics about each of them, and then plotting the results of those class activities on different types of statistical plots. And then there was Patrick Honors, I'm not sure exactly how to pronounce his name correctly. This was one of the first Rosenthal Prize lessons back in, I think, 2012. And it's about sphere dressing. So you take a small styrofoam ball and you turn it into a head, and you have to design a geometric hat for the sphere head. So that's a geometry lesson. So there's all different lessons: geometry, statistics, probability, proportions, computations. There are lessons on sort of standard junior high topics. There are also lessons. There's one on recursion. That's more of something you wouldn't see in the standard lesson, but a junior high student could do it, could understand it, right? So it doesn't have to be something that's necessarily in the Common Core curriculum for a junior high student, as long as it's something that a junior high student could participate in and understand, right? So next slide, we're going to talk about how do you go about applying for the Rosenthal Prize, and what does it entail? Do you want to talk to this one, Sarah?
So the Rosenthal Prize is judged in rounds. There's a first round and then there's a finalist round. The first round is very straightforward. You're going to use 250 words to describe your lesson. You want to paint a picture of what the lesson is trying to accomplish. It should be geared towards middle grade, so they consider that to be 4th through 8th grade. It's really about the lesson and not the teacher. The goal of the Rosenthal Prize is to get engaging lessons in the hands of as many teachers as possible. They rate the lesson against criterion. And then after everybody, I think the first deadline is in May. And after those ones come in, they judge them, and then they will select finalists. And the finalists will do a more detailed lesson plan, including a 45-minute video of you teaching the lesson at the appropriate age level. You do not have to be a classroom teacher to win the Rosenthal Prize, but at some point you do need to teach the lesson to, 6th, 7th, 8th, 4th, 5th grader students, so they can really see students engaging with your idea. And so first round is in May. I think the finalists, you get notified in the fall, which gives you a lot of time to put that video together. And then the winners will be announced in February. First place is $25,000. And then there's usually some runner-up prizes. All of the winners are flown to New York and honored at the museum. And the museum will pay for your travel and your hotel. So I think and I'm hoping if you guys have questions, you're dropping them in the chat.
Yeah. So this is a list of some of the things that are off of the rubric that they're looking for. The initial stage of an application is not a time intensive thing. All of them are like 250 words or less or 500 words or less. So they really emphasize that you want to spend your whole 250 words talking about the lesson, not introducing yourself or the context of the students. Like, just talk about the lesson, because you have a very short amount of space to describe the lesson. So it should be innovative. It should be like either something you've created or something you've put your own spin on. So how have you added new or important details to a well-known task? I think Dan Finkel's prize-winning lesson from this year, he said he didn't create that lesson. That lesson is an old lesson that's been around for a long time. He just added to it. He put his own spin on it and made it a bit more engaging and a little bit more easy for students to understand. It should be inspiring and engaging. It should be a fun activity. There should be some math content to it. Typically, math content that's with something that a junior high teacher or a upper elementary teacher would teach to students, so they have an opportunity to teach it. I think Sarah already talked about it should be replicable, and it should be. They talked about connectedness. Does the activity have an impact? Is it something that students would see themselves in, or be part of the curriculum that they would see? And then there's one thing that, of course, always just the narrative. Is it well written and easy to understand? Is it clear, concise? Is it free of typos and grammar and spelling errors and all those sorts of things? So we want to take some time now just to answer some questions. If you had questions about the application process or how to apply, or the sorts of things that they're looking for in an award-winning lesson.
Can you show us again where they would go to apply and find information, that sort of thing? And when was the deadline again? It was like May something?
May 15th is the first round.
And do you know when people get notified that they've gone on to the second round?
Based on what Cindy said yesterday, I kind of feel like by September, Eric, is that ringing a bell? Because I kind of got the impression that you would know at the beginning of the school year so that you could teach your lesson again and get that set up in a classroom. And the other thing I want to add about the prizes is, Eric and I were both part of the Institute, and we are going to speak to that here in a minute. But once we were at the museum, and you really see the goal of the museum is to pull any visitor in to an exhibit. And, when I walk into an art museum, I don't feel like I have to be an expert at art to enjoy what's going on. The math museum is the same way. It shouldn't feel like I have to be an expert mathematician to enjoy the museum. The lessons are the same idea. You want students who don't have to feel like they're the smartest mathematician ever to enjoy your lesson, be engaged in it, and take something from it. So that's what was happening at the Institute, is we'd go and we'd check out the museum, and then we'd bounce back and look at the lessons and kind of talk about how the lessons were engaging, just like the exhibits at the museum were engaging.
So the application rules say early July is when the results from the preliminary round are announced. So if you apply in May, the application closes in May, you should know in early July if you're moving on to the final round. And then here's the instructions. I'm just going to open up the application form and take a look. So the first questions are just sort of biographical information, name, email addresses, school information, where you teach, what grades you teach, or other spots, some professional reference, And then the main questions here: describe an innovative activity appropriate for use in 4th through 8th grade. And you notice it's please answer in 250 words or less. So that gives you you have to have a very quick, concise description of your activity. Specific grade level, a brief essay explaining how this activity represents your teaching or math outreach philosophy. So why do you think this is a great lesson to share with other teachers? And then describe, is this activity original to you? Did you create it? And if it's from somewhere else, do you know where it came from? Sometimes a lesson might be so old you really don't know. It's just been around forever. But if you know where you saw it originally, that would be helpful to the judges as well. Imagine that another teacher were trying to implement your activity in their classroom. If they had to start from scratch, what materials would they need? So this is that replicability part of it. What materials would you need in order to do this in your classroom? And the last question here is, have you used the activity with 4th through 8th graders? So have you actually done this activity before? Did you just sort of come up with it, think about it, or have you actually tried it out and done it before? So that's it. That's the whole application. So you'll notice that it's not a long application. It doesn't take a long time to do it. It'll probably take you longer to think up what's a good lesson that I want to share than to actually fill out the form for the lesson.
Eric, are you ready to talk about the Institute?
Yeah.
Okay. Do you want me to talk about it?
Why don't you start us off and I'll jump in.
Okay. So last summer was the first Rosenthal Summer Math Institute, and they had 14 educators come and spend 2.5 days at the museum working as a small cohort. And the goal of the Institute is for educators to dive into these lessons and then commit to taking these lessons back to their districts, their ISDs, their states, their regions, and present them to their colleagues to basically, I think the idea is that they've given this money, prize money out for these great lessons, and that they were sitting on a web page and not getting out to educators. So the goal was to bring educators in and say, we want you to know these are here and talk about how to use them. So what we did was, all your travel is covered. The meals were covered. We did 2.5 days. We did math together. We looked at these lessons and we went through the museum, all parts of the museum. And we applied. I think the application is going to open up soon. We found out by June 1st if we were going or not. We went late July. And I think the other piece that I need to throw in is that, being a teacher is hard. And for me, I teach at a very small rural district. This is my 23rd year. I needed to be around some other educators and broaden my network and get energized and inspired. Not that my colleagues aren't wonderful. They are wonderful. But it's hard out there. And so I was looking for something to kind of, just expand my network. And like Megan said in the chat, it was a blast. And the museum took excellent care of us. There were evening activities. The meals were covered. We had a rooftop dinner. We did a sail around the Statue of Liberty at night. Lots of cool stuff. And so if you're thinking there's a couple of pieces to this, you can, if you've got a great lesson, apply for the prize. If you're interested in being a part of the next cohort of educators, apply to go to the Institute. It's 3 days well spent.
Yeah, I'd agree. And I think it was really nice getting a tour of the museum from Tim Neeson, who actually was the designer of a lot of the exhibits, to have him talk to us about how they got chosen, why they were chosen, what about those exhibits made them special, and what brought out that joy and beauty of mathematics, and how that related to the same sort of things that were coming out in the lessons we were talking about. So I think there's a close relationship between the types of experiences you have in the math museum to the types of experiences students might have doing some of these lessons as well. So this is a couple of pictures from last summer. That's a couple of us this is one of the classrooms in the bottom floor of the museum where we were. It was just a small group, 14 of us, plus Ralph Pantozzi was our facilitator who walked us through a bunch of the lessons. And we had it's a really nice facility. All the walls are 100% whiteboard, so it was a really great space to collaborate and share and work with other teachers. So Shirley asked, is the institute only for middle or junior high school teachers? No, I'm a high school background teacher. I think Sarah, you were high school as well before this year, right? But you have to have access to junior high classrooms. So I teach in a spot where I can be in high school and junior high classrooms. So I'm often in junior high classrooms as well. But it's not just for middle or junior high teachers. You can be an educator at any level and apply for it.
Eric, we've got a question from Larissa. She says, did you say the expectation is that the lesson is entirely completed within a 45 to 60 minute class period? Would it not be advised to submit a lesson that requires students to do work prior to the lesson?
So I think the expectation was that the main body of the lesson should be around 45 minutes, but that there's lots of opportunities for extensions. So to have those extensions or places to go afterwards are really great things to have. But you wouldn't, I think they talked about, you wouldn't want to have like a week-long unit as your submission, right? That's too much. That would be a barrier to teachers doing it in their classroom. So the idea would be the main focus of the lesson be sort of a day's lesson, but definitely it's definitely a benefit to have extensions. They say if you were to do it a second day, where would you go from there? But not to have it a long drawn out process that might inhibit that. Some teachers might not have that much time to devote to a single lesson, to devote multiple days. It might not be as easier for teachers to be able to implement in their classrooms if it was too long. So there's only 4 questions on the application for the Summer Institute. The questions for this year aren't up. These were the questions from last year, so I just put them up there in case you wanted to see what sort of questions were asked. Very similar to the questions from the prize. So sort of like beliefs about your educational philosophy. It asks you to review one of the Rosenthal Prize lessons. So describe one that you think is a great lesson and the one that you might have already used in your classroom or would be interested in using. So a review of one of the lessons. What's your interest or experience in sharing at conferences and professional development meeting? That, of course, is not a requirement for selection. They're just curious to see what your experience is. And if selected, you'd be asked to implement some of these lessons in your classroom or share with students and teachers in the community. And so they want to say, what are some ways that you might do that you could consider doing that based on your current context about where you're teaching and who you're teaching with. So 4 questions. I think it took me, I don't know how long it took you, Sarah. I think I took 2 hours to actually do it, and then I came back to it later. It was actually about this time that I heard about it last year, and I actually waited until the 4-day Easter weekend. And so then I did it. I had a little extra time during the weekend. And well, in Canada, it's a 4-day Easter weekend. I don't think it is in the States. That's the time that I did it. So I wrote all my answers out and then I sat on it. And then I came back to it. I went through it with some to check for typos and make sure it was clearly written, reread it again and made some more changes. And then I submitted it. So total time for me wasn't more than 2 or 3 hours, I think. I don't know about Sarah, what it was for you, time to do the application?
Probably about that. I waited till the absolute latest minute possible. So, and the other thing I want to add about the Institute is you also are kind of committed to kind of an ongoing commitment. So we've been meeting via Zoom maybe every other month, and there is a stipend attached at the end of everything. And I can't remember the exact dollar amount.
It was
Erick, maybe you
$750.
can, but yeah. And what the museum and so Rosenthal are what they're essentially paying us for is to get these lessons in the hands of teachers. And so that's what we're committed to doing. And so we meet every other week or every other month and talk about how we're getting
For me,
the word out there.
it was the money allowed me to register for a conference that I was able to present at.
Yeah. We definitely want to honor your time, and it's been an hour. Other questions about the prize, about the museum, about the Institute, anything you guys want to know?
If you do have questions, Sarah and I are both on Twitter, so you can feel free to message us or post to share us a question on Twitter, or that's probably the easiest way to get a hold of us. So we look forward to, if you have any questions, feel free to reach out anytime, and we can help you with any questions you have about either the Summer Institute or the Rosenthal Prize application.
And the only thing I would throw in at the end is exactly what Cindy told us yesterday, which is apply for the prize and apply for the Institute. So.
Yep. Thank you so much. That I wish I knew about this when I was teaching at that grade level. Since I'm a college person now, I can't do this, but I am going to go to the Museum of Math. I have not been there yet. So I'll definitely.
Actually, the winner from last year was a college professor
that
they were a professor, and they found a junior high classroom to go do their lesson in.
Mm-hmm. All right. I'll have to think about that. That'd be exciting. So yes, thank you very much, both Erick and Sarah. And thank you for everyone in attendance. Thank you for joining us. Our next webinar is March 7th. And the topic is Talk Number to Me, Mathematics and Mindfulness with Christina Lincoln Moore. Have a nice evening, everyone.